Hello everyone. So today we are presenting on the topic K nearest neighbor classification under the subject AML. So my teammates are Qamruddin, Prajwal, and Sachin. So our problem statement's objective is to build and evaluate a KNN classifier for a real-world dataset and experiment with the different values of K. And the expected outcome is to first make a trained KNN classifier with performance metrics like accuracy, precision, recall, and the confusion metrics. Let me show you the real-world dataset that we are using. Yeah, so this is the dataset we are using. Yeah, so this data is by MESC and it's a CSV file with around 32 columns, 32 different parameters. All are not visible here, but I'll show you later. Let me show you the contents of the file. This is the file, and if you open it, yeah, so this is the ID, this is diagnosis, and M stands for malignant, and B stands for benign, and these are all the different parameters. There will be 32 of them. The malignant means that those cells that can reproduce quickly and in themselves and cause cancer very quickly, and benign means those cells that reproduce that also reproduce but reproduce at a very slower rate and don't cause as much damage as the malignant ones. So uh, dis- uh, let's explain the code now.
First, we import all the necessary libraries. Pandas and numpys help us to handle and process the data. Matplotlib and Seaborn are used to draw graphs and visualize the results. From a scikit-learn, we import functions for splitting data, scaling features, KNN classifier, and evaluation metrics like accuracy, precision, recalls, and confusion metrics. Next is load dataset. df equals pd.read csv. Next, we load the breast cancer dataset from a CSV file using pandas. Next, we check the shape of the dataset to see how many rows and columns. We also look at the first few rows using head to understand the type of the data we have. Next, data pre-processing. After the loading data, we clean it. We remove the ID column because it is not useful for prediction. df equals df.log. df.column string contains unnamed. We also remove any unnamed columns that sometimes appears in CSV files. Then we convert the target columns diagnosis from letters to numbers. Malignant M becomes 1 and benign B becomes 0. This is necessary because machine learning models only work with numbers.
Thank you, Qamruddin. Next part of the code will be taken up by me. X is equals to df dot drop diagnosis x axis is equals to 1, y is equals to df diagnosis. The features x are the columns which accepts the diagnosis column, which is the target. The target y is the diagnosis column, where malignant is equals to 1 and benign is equals to 0. Next, X train, X test, Y train, and Y test. It splits the data into X and Y into four subsets: X train, X test, Y train, and Y test. It allocates 80% of the data into training and 20% of the data into testing. So the test size is 0.2 and random state is 42. This ensures the split is same every time the code runs, making the result reproducible. The main purpose of this is the training data is used to train the KNN model, and the testing data is kept separate and is used to evaluate the model's performance on unseen data. Feature scaling. Let's come to the next part of the code. Scalar is equals to standard scalar. Initializing the standard scalar. This technique transfer features to the mean of 0 and standard deviation of 1, where z score is normalization. Xtrain scaled is equals to scale dot fit transform xtrain. This fits the scalar to the training data, calculates the mean and standard deviations, and then then transform it. This prevents data leakage. So xtest scaled is equals to scalar dot transform xtest. This transfers the testing data using the mean and standard deviation learned from the training data. The main purpose of this part of the code is it ensures all the features contributed equally to the distance calculation, preventing features with large values from dominating the calculations over features with small values movements. So let's come to the next part of the code, which is model training and evaluation loop. This segment iterates through different values of k, which is the number of the neighbors, to find the optimal parameters of the KNN model. K values are ranged from 1 to 21 and with the accuracy scores. It defines the range of K values to test 1 to 20 and initializes an empty list to score the resulting accuracy for each K values. For K in K values, it starts a loop iterates over K each K from 1 to 20. K is equals to K neighbors classifier. It creates a new KNN model instances for the current value of the K. KNN.fit X train scaled Y train trains the model using the scaled training data. Prediction KNN dot predict extend X test scale uses the train module to make predictions on unseen and scaled testing data. So accuracy scores dot append IACC stores the calculated accuracy in the list for later analysis and plotting the code. It generates a line plotting showing that how the accuracy changes as number of the neighbors increases. This visualization helps in determining the best k value. So the main purpose of this part of the code is known as hyperparameter tuning. Systematically evaluates the model's performance for different k values to select the one that yields the highest accuracy. So this comes to an end that part of the code explained by me. So next part of the code will be taken up by my friend. Thank you.
So here in this code part, we'll be discussing about plotting the graph for the model which we have choose. So first plot is we are gonna choose the accuracy for different k values, and we are gonna pick the best k value with highest accuracy, and then analyze it using performance matrix. So what this code tells is we are gonna plot a graph using the figure function to select the layout, and then we'll plot for two different values, that is k values and accuracy scores. So the title, label, and x label and y label are for representation and for knowing what the graph is about, and then grid true for enabling the graph, and we are going to show the graph using plot.show. So next thing is select the best k value. So what it does is, so best equals k is a variable which has been created where np.rmax finds the highest index and returns the highest accuracy, then which is stored in best k variable. Then we are going to print the best k variable that has the highest accuracy score. Then we will create a new KNN model for the best accuracy score. So where the model is trained on dot fit function and is based on training data and predicted using test data by using the function dot predict. So the next part is performance metrics, where the performance of the model is evaluated. First one is to calculate the accuracy for the test data and the prediction data. And then the precision score for that test and prediction data. Then we have calculated recall and confusion matrix for the respective data. Now we will move on to the graph which has been shown as the output. So as you guys can see, we are evaluating or selecting the highest accuracy. So here is the graph which is plotted using plot library. So there is two functions. First one is number of neighbors and accuracy in the y-axis and numbers of neighbors in the x-axis. So where the accuracies has been selected. So the highest accuracy has been selected at 0.965 for 9 number of neighbors. So which has been trained on that. Based on this value, accuracy is generated, precision and recall, and finally confusion matrix is developed.
Thank you, Sachin. So let's move on to my part of the code. Print line number 7 from line number 73. Print model performance. So this will print model performance on the output screen. Then followed by three more print statements that will be printing the accuracy, precision, and recall. So we can, as you can see, we are calling these accuracy, precision, recall, which were defined here. Line number 68, 69, and 70. And these dot 3f define the number of decimal places that will be printed on the output screen. So since here it says dot 3f, so total of three values will be printed after the dot value. Next, we are printing the classification report defined in 78 and 79. So this will be printing the classification report like this one, like this, and we are putting the labels as benign and malignant to make it easier to read. Now, basically, this will print out the precision, recall, and F1 score of the benign and malignant, along with the macro average and weighted average of the accuracy, making the confusion matrix. So this is the figure size we are giving. Then we are creating a heat map of the confusion matrix. So we are labeling the x axis as benign and malignant, and the y labels as benign and malignant. So as you see here, so this is true positive, this is true negative, this is false negative, and this is false positive. Then we are labeling it with the title of confusion matrix with k is equal to best k. Now earlier in the code we have defined what is the best value of k, which in our case is 9. As you can see here, best value of k is 9. Then we are printing the x label as predicted and the y label as actual, and then we are just printing the uh, confusion matrix on the label screen, output label screen. Let me show you the output now. So first, so first we are printing the first five rows of the dataset. As you can see here, it has a total of 569 rows and 32 columns. The first column has the ID along with the diagnosis, as I stated in the earlier. M stands for malignant and B stands for benign, and these are all the other different parameters. A total of 32. Uh, this was the number of rows and columns that we actually printed from the dataset. Then this is a graph representing the accuracy for each value of k that was calculated. As you can see, for somewhere between 1 or 1.5 value of k, we are getting the lowest accuracy, and for 9 we are getting the highest accuracy. So naturally we are selecting this as the best value of k, and that's what is written here. Now this is the model performance of the model, and accuracy stands with 0.96, followed by precision and recall with 95 and 0.95 and 0.95 respectively. So what all these three parameters mean is, so accuracy stands for how many total predictions were correct. Precision stands for out of all predicted positive cases. For example, in malignant in our case, how many were actually correct. And recall says us out of all actual positive cases, how many were correctly predicted. Next part. This is the classification report. Now this has four things: precision, recall, F1 score, and the support. So let me explain each one of them. So F1 score represents the harmonic mean of precision and recall. The support represents the number of test samples in each of the classes. The macro averages tells us the average of matrix for each class, and the weighted average defines the average weighted by the number of samples per class. Now let me show you the confusion matrix. So here it is. Yeah. So as the label says, this data is for the value when k is equal to 9. So these are the actual values and these are the predicted values. As you can see, when the actual benign and predicted benign are equal to 69, the actual malignant and predicted malignant are 41, which are very good numbers. And these are the false values, negative values, which are 2 and 2 respectively, and which are considered very low. So our model has performed very good. uh, that's all for today. Thank you.